Assalamualaikum and hello everyone. We are from AS12055 and for this video we would like to present about HPLC, which is the high performance liquid chromatography. Before we start, allow me to introduce our group member first. My name is Nuranisha binti Omar. Our group member is Siti Mariam, Nino Aira Natasha, Wanut Syazatul Amira, and Alia Maisara. For this video, we study about introduction of HPLC, objective of the experiment, methodology, result discussion, and the last one, the conclusion.
Assalamualaikum. Today we're going to talk about HPLC. HPLC is a high performance liquid chromatography, a widely used analytical technique for separating components in a mixture. In this method, the components are separated on a column packed with a silica-based particles known as the stationary phase. A solvent, called the mobile phase, is pumped through the column. Each component in the mixture refers to as the analyte interact differently with the stationary and mobile phases due to its unique affinity. This difference in interaction causes analytes to migrate through the column at varying speeds, leading to their separation and allowing them to emerge at a different times. This process is crucial for analyzing complex mixture in various fields. Next, we go to the mobile phase and stationary phase. For the mobile phase is a liquid solvent or a combination of solvents that flow through the column. It carries the analytes and facilitates their movement. Selection of the mobile phase depends on the analyte's properties, and it can be either polar or non-polar. For stationary phase, the stationary phase is made of silica based on particle packed inside the column. It interacts with the analyte based on factors like polarity, size, and charge. Depending on the type of HPLC, the stationary phase can either be polar, normal phase HPLC, or non-polar, reverse phase HPLC.
So, next we move to the objective in this study. So, in this study have three main objectives. First, to determine the retention time of standard solution, caffeine. Secondly, to identify the caffeine peak in soft drink sample. The last one, to determine the amount of caffeine in soft drink sample using response factor method.
Okay, let's move to the methodology. This slide shows the schematic diagram of an HPLC system. The main component include the solvent reservoir, the pump, the injector, the guard column, the analytical column, the detector, and the data system and display. After that, I will explain more details about the function and name of each component of the HPLC instrument. The solvent reservoir are used to store the mobile phase, which may consist of a single solvent or a mixture of solvents. This mobile phase carries the sample through the system. The pump is crucial for delivering the mobile phase at a consistent flow rate, ensuring smooth operation. The injector introduces the sample into the mobile phase stream, allowing it to enter the column. The column is the core of the system where the actual separation of compounds takes place. Once the compounds are separate, the detector identifies and measures them as they elute from the column. The data acquisition system, commonly referred to as chromatography software, processor and collect the data generated by the detector. To ensure accurate result, the degasser removes dissolved gas from the mobile phase. Lastly, the column oven maintains a stable temperature for the column, which is essential for optimizing the separation of compounds. Each of these components play an integral role in achieving precise and efficient HPLC analysis.
So now we want to talk about results and discussions. This is the results that we found in standard caffeine, caffeine in Cook, and caffeine in Labita. The rotation time for standard caffeine is 2.482, caffeine in cook 2.481, and caffeine in Lavita is 2.479. For a peak area of caffeine, we found that standard caffeine have 6249.486779, caffeine in cook 7001.12305, and caffeine in Lavita is 1.1151, exponent 4. Last is concentration for standard caffeine is 100. Caffeine in Coke 112.0271 and caffeine in Lavita is 178.432. Alright, now I want to explain about this result and discussions. First, standard caffeine. This chromatogram graph shows the rotation time of caffeine found in standard caffeine, the presence of caffeine in this sample at minute 2.481. This is because it corresponds to standard caffeine's rotation time of 2.482 minutes. We use the formula of response factor caffeine standard equal to peak area caffeine standard over concentration of caffeine standard, and the result is 624.4949 milliabsorbents per second. Next is caffeine in Coke. This chromatogram graph shows the rotation time of caffeine found in Coke, the percent of caffeine in this sample at minute 2.482. This is because it corresponds to the standard caffeine rotation time of 2.482 minutes. We use the concentration of caffeine in the unknown sample formula equal to peak area caffeine in sample over RF, and the result is 112.0271 ppm.
So, next, we move to the last result and discussion for our study, which is a caffeine contents in Levita. Based on the chromatogram graph, show the rotation time for caffeine present in Levita. The caffeine present in sample at 2.479 minutes. It is correspond to standard caffeine rotation time, which is a 2.482 minutes. Then we use this formula to find the concentration of caffeine in Levita. 1.1151 times 10 power of 4 MAU times S is a peak area are provided in sample. Then over 62.4949 MAU times S per ppm. This is a RF. Then the unit MAU times S can cancel. Then we get the result. Concentration caffeine in Levita is 178.432 ppm.
And the last one is the conclusion. The high-performance liquid chromatography HPLC experiment successfully demonstrated the separation and quantification of caffeine in the given sample. The objective of the experiment, which is include identify the caffeine peak component in mixture, determine the retention time and amount of caffeine were achieved. The retention time for standard caffeine solution, caffeine in Coke, and in a Levita were 2.482, 2.481, and 2.479 per minute, indicating consistent peak identification and confirming the accuracy of the method in identifying the caffeine peak. The experimental data support the use of HPLC as a precious and reliable analytical method for detecting and quantifying caffeine. We calculate the caffeine concentration using the response factor method. Caffeine in Levita is 178.432 ppm and caffeine in Coke is 112.0271 ppm. This finding demonstrates the effectiveness of HPLC. Furthermore, other instrument method that can be used except HPLC is UV-vis spectroscopy. It could be applied to analyze caffeine content. UV-vis spectroscopy is suitable for preliminary quantification of caffeine. This technique can enhance the reliability of caffeine analysis in various applications. In addition, this study highlights the broader application of HPLC in various fields such as pharmaceutical, food analysis, and environmental monitoring due to its high sensitivity and accuracy in separating complex mixture. Thank you. That's all from us.